Okay, we're going to take a look at exponents and exponential relations review. Just so you're aware, there are a number of equations that go along with exponential relations, and all of them will be given to you when you're working on your exam. So just please be aware that these 5 equations that are presented to you will also be on the final exam, and you don't have to worry about writing them down. So what I wanted to quickly start off with is by looking at the exponent laws. And we talked about 5 different exponent laws as we went through our exponent unit. And so our 5 different exponent laws are all listed for us here. We talk about what we do when we multiply, divide powers with the same base. We've also looked at what we do when the exponent is 0. We've looked at what do we do when there's a power that's raised to an exponent, and what to do when we have a negative exponent. So let's go through and evaluate each one of these things. So in this instance, we always want to express as a single positive power and then evaluate. So that means actually solve it. So what is it? What's the final answer? And in fractions, not in decimals. So in this case, we've got 2 to the power of, 2 to the exponent 7 times 2 to the exponent 2. So when we have an exponent with the same base, okay, what we end up doing is we add the exponents together. So in this case, uh, both of these 2 powers have the same base. The base is 2. And so what we're going to do is 7 plus 2. So that gives us 7 to the power of 9. And so now what we're going to do is actually evaluate that. So in our calculator, we would do 2 to the exponent 9. And so that's going to be 512. The next one that we'll take a look at here is on the right. We've got powers, both to base 3, but in this case they have very large exponents, which can look very intimidating, but this is actually quite simple. We take, and it's a to the exponent m times, or sorry, divided by a to the exponent n. That's the same as saying a m minus n. It's supposed to be an m. It's a terrible m. Let me try and fix that. So we just simply subtract the base. Okay. So in this instance, we've got our base is 3. We've got 2011 minus 2008. Okay, so 2011 minus 2008 is 3. And so this is actually going to equal 27. Because 3 to the exponent 3 is 27. Next, we want to take a look at, well, what do we do if we have an exponent that actually has no exponent written here? I'm going to change my pen color just so it's a little easier to see. So in this case, I've got 4 to what looks like no exponent. And when there's no exponent that's written, we actually have to note that it's actually the exponent 1. So this is a multiplication thing, so we're going to be multiplying these two, or sorry, adding these 2 exponents together. So they have the same base, 4. So 1 plus 2, should all be able to do that. So 4 to the exponent 3, and then so if I plug that into my calculator, 4 to the exponent 3 is 64. Okay. A new thing here, we've got on the right-hand side, we've got 3 squared. That's our power, and then that power is being raised to the exponent 5. So in this instance, when you've got a to the n, and it's to the exponent m, that's the same thing as saying a is to the exponent n times m. Okay, so we're going to actually multiply these 2 exponents. So what we're going to do is we're going to take 2 times 5. Okay, 2 times 5 is obviously 10. So we're going to do 3 to the exponent 10. So when I do 3 to the exponent 10, it actually gives me a very large number of 59,049. Again, we'll just move down one more. Change our pen color just for variety's sake. We've got 5 to the exponent 0, and this one should be really easy. Because frankly, any number written to the exponent 0, or any number raised to the exponent 0, is just equal to 1. Okay? So anytime you have a 0 as your exponent, the number is just equal to 1. Now we're going to get into a negative exponent. Okay? And our rule with negative exponents is that first off, we need to turn them into positive exponents. So we do the positive inverse. So 3 as a number is the same as 3 over 1. Okay? The inverse means to flip. So we want to flip the base and make the exponent positive. So right now, we've got 3 over 1 to the exponent negative 3. If we flip the base, what that becomes is 1 over 3, and then that's all written to the exponent 3. Okay? So that exponent of 3 is then actually applied to both the top number and the bottom number. So this 3 is applied to the 1, and it's also applied to the 3. Okay? So what we end up with here is actually 1, because 1 to the exponent 3 is 1, and 3 to the exponent 3 is 27. So our answer is 1 over 27. Okay? Next, we've got a negative 4 in brackets, all to the exponent 2. Okay? When we have a negative 4, that's the number that's being squared. What this means is the same as negative 4 times negative 4. Okay? So if I have negative 4 and I square it, that's going to give me positive 16. Okay? Because it's negative 4 times negative 4. Okay? So on my calculator, I have to actually put the negative 4 in brackets and then raise it to the exponent 2 to give me the positive 16. Okay? So if you want to put that properly into your calculator, you actually have to do negative 4 raised to the exponent 2. Okay? So that's just, at least in my calculator, that's how you plug that in. That upside down V is an exponent sign. To the right here, we have negative and then 4 squared. This, you'll notice, this does not have brackets on it. And what that actually means is that it's negative 1 times 4 squared. Okay? So by the rules of Bedmus, what we're going to do is we actually have negative 1 times 16, because 4 squared is 16. And then negative 1 times 16 gives us negative 16. Okay? So it's important to note that the brackets around negative bases is really important. It will change your answer. So make sure that you appropriately input that, or properly input that into your calculator. So next, what we're going to do, got one other piece here that we need to continue on with. There's another example that I want to go to, and that's actually right up here. This one's a very interesting example because it combines multiple laws together. Okay, so here we've got, this is the question I'm referring to. We've got 2 to the power of 3 times 1 times 2, all divided by 2 to the exponent 9. Okay, so first off, we need to recognize that there's actually an exponent on top here, and that's a 1. Okay, so we're going to use our exponent law because we've got 2 to the power, or 2 to the exponent 3 times 2 to the exponent 1, and they're being multiplied. We actually add those two things together. So this is actually going to equal 2 to the 4 over 2 to the power of 9. Okay. So 2 over 4 divided by 2 to the power of 9, you can also write that as 2 to the 4 divided by 2 to the power of 9. Okay, and so it's a division question. So we know that this is actually going to end up being 2 to the negative 5. Okay, because 4 minus 9 is going to give us negative 5. So now we've got our power, but it has a negative exponent. So we need to turn this around. We're going to now use our exponent law where we've got negative numbers or a negative exponent. We're going to flip the base and write the exponent as a positive number. So again, 2 is the same as 2 over 1. Okay, so this is the same as saying 2 over 1 to the exponent negative 5. So what I'm going to do is I'm going to flip the base. And this is going to give me 1 over 2 all to the exponent positive 5. Now, that means that I've got 1 to the exponent positive 5 on the top, and 1 to the power of 5, or to the exponent 5 is 1. And then I've got 2 to the exponent 5. So if I do 2 to the exponent 5, that punches out 32. Okay, so my final answer for this particular question is 1 over 32.